Hi, welcome back. So last time we talked about LLMs and how they fit into information retrieval. And today we're going to talk about embedding models, which is a way to extract meaning from language. And even though sort of embedding models sort of predates LLMs, it's a very common technique, and both embeddings and large language models are very common. They're used in industry and academia. And the embedding models are very good because they give you more control than working with LLMs. And so embedding models have sort of been around for a long time in sort of different versions. And I will not talk about the history of all of them, but basically we have a GLOV and Word2Vec and different versions of that. And bidirectional transformers, which came out in 2018, had a way to realize that we can, instead of modeling just words, we model a sentence, and we model how this sort of sentence fits together by masking, training it on masking a word, and through that you can sort of get a bidirectional, but technically it's like all directional, because you mask one part of the sentence and you do that while you're training, and then you get a full understanding of the complete sentence. So by doing that, you sort of use an attention mechanism and sort of train a model to get the output, which is a vector representation of language. So the input is text, and then the output is an embedding, which is a vector representation of language. And this, in this embedding space, there's a notion of directionality, where how close something is to something else shows how similar these concepts are in the vector space. So you can think of this sort of also how children learn language, by sort of looking at the mask of something and having, okay, mask a word. So to be or to be, that is the question, is how these models learn. And this has been highly influential, and I would say except for GPT models, like transform models, like for generative language, these sort of embedding models are probably the most common models used. And there's many things, including retrieval systems for LLMs. Right, and why embeddings are very important is because they give you sort of the meaning of language. So, and this is of course different from the sort of the semantic representation of language, or the grammar. It gives you an understanding of the underlying meaning of the language, right? And you can use similarity methods to check how similar things are. And by using this, you can train models to classify language. And this was we could do this previously, but the sort of embedding models made it sort of cheap and easy to do, right? But you can also go further and use the embeddings to train systems. For instance, for making a system for named entity recognition, you can use the embedding models and the embeddings, and then you train the system to classify based on that. And for instance, here's a paper we wrote on classifying mental health using embeddings. So here we combined using large language models and embedding models. And I think a very nice thing you can do nowadays is you can combine these different paradigms, right? So we used the LLM model to generate sort of descriptions of how someone would sound or describe themselves if they had different symptoms on a score of different things. Someone who had a lot of PTSD or depression would sound like this. And based on this, we made a regression model. But based on the embedding, it gives you the score. How many points does this person have in the score? So this is sort of a way to think about, like, practically how can we use embedding models in practice. And basically you think about like any problem where you have language and you want to classify, you can use embeddings. So this is a lot, right? There's so many problems or sort of scenarios where you can use embeddings. And one thing that's very nice with embeddings is, for this instance, right, you get a real result. You sort of get a classification result and some other result, and this makes it more secure in one way than using LLMs, right? So this is sort of a nice way to use these tools in a more clear way. Right. So one question, of course, is like, okay, when should I use embeddings, and when should I use an LLM? And of course, when you know what you need, let's say you want to classify codes for medicine, like diagnostic codes. There are a discrete number of codes, right? You can only have this many disorders, and you want to classify the right one, right? Then it could be nice to use embeddings. You have some kind of text, and you want to classify it to embedding. And hopefully even better if you have the data, you can have like the right labels, you can check it, right? But if you have an open-ended question, what is the meaning of life? There is no good way to use embedding for that. Another good way when we only use embeddings is when we have a large-scale data set, right? So millions of documents, right? So of course we talked about this earlier. For LLMs, there's a limit to the context, right? And if you think about the scope of the internet and all available information, it is way more than for even the largest LLMs. So even if it would be feasible and you have the money to do it, it's not a good idea to put everything in LLMs. But if you have a large-scale data set and you want to structure it, embeddings are a great way to do that. And one of the more practical use cases of combining technology is using embedding systems for something called retrieval augmented generation, when you structure all your documents inside the database, and then you can use embeddings or sort of a query for embeddings to get this information out and use it in combination with a large language model. So it's a very common way to use them. Another nice way, but I guess sort of in this scenario, you might want to add an LLM, because if you only had the embedding, you would just get the answer out, right? Let's say you have some legal text, then you just get the text out, but you might want the sort of LLM to sort of give you a nuanced understanding of the text. So this way they can work really nice together, so that the information comes from the embedding, and the sort of nuanced understanding and sort of context for that comes from LLM. So they work really nicely together. Another scenario when it can be nice to use an embedding model is when you have on-device processing. If you're using something, because embeddings can be really small and still useful. And for something maybe medical, but other things, it's nice to have something on device. So then you can use an embedding model. The smallest embedding models are less than 1 billion parameters, so they're quite small. So this means they can fit on basically all the phones and other microprocessors. Right, of course embeddings wouldn't work for like make a creative story, right? They don't work like that, so they can't sort of generate language in that way. That's not what you use them for. And embeddings, of course, are small and lightweight, so they can sort of handle larger amount of text than LLMs. But at the same time, LLMs are better for conversational tasks. And sort of most systems in some way that are running, sort of ChatGPT, other systems, have some kind of embedding system for tracking, for using, for retrieving context. For instance, Google themselves sort of invented BERT, but also used this for retrieving web documents, right? So this is something that's used basically everywhere. And another question is sort of like, okay, we have embeddings, but what embeddings should I use, right? And luckily, and this is sort of true for many areas in research, that there are people who sort of have benchmarks of what are the best tools, right? So one thing you want to do is you want to check these benchmarks, and that both checks for your language maybe and for your task, what's the best one. And then you can think about for price performance, right? How good does it need to be? And when working with embedding, it's a very good idea to sort of have structured tests to make sure that you're testing this. So for your task, how good embeddings do you need, right? And in general, I would say right now the embeddings are quite good. So depending if you have a sort of a high resource language like English, most embeddings work. A low resource language, that could be Swedish and could be even rarer languages, you might have to check more that make sure that the that embedding work for your language, right? And here you can think about this, that the embedding works well if the text you are using is something that the model was trained on. So let's say you're using Swedish medical text. Then the question is, do we think that this embedding model was trained on this type of text? And then we can try, of course, we can always try. But if we know that we have an embedding that was trained on this type of text, it's going to work better. And we can, of course, make our own models. But in general, the way to think about this model, is it trained on the text I'm trying to use it for, right? Because that's sort of the embedding space it has. And that's one way to think about like what model to use. Right. And the speed and the cost of embeddings is also important. So for instance, if you want to, let's say you have 1 million documents, or maybe you have 1 billion documents, at some point it sort of matters how quickly you want to retrieve them. So and the speed and cost goes together, right? So and what I mean by size is sort of like how large will the embeddings be that the models will give you, right? So a larger embedding space will have more nuance, but it's going to take more time for you to sort of process, and the smaller embedding space will be quicker to process, but might be not as nuanced. But I think in general, it's sort of optimizing for something that works, and sort of this is something you need to check. You need to check how good are the embeddings, right? And try some different ones out, right? And of course, today we don't only have embeddings that are sort of for one dimension. We have multimodal embeddings. So this is a recent embedding model came in from Google. But in general, we have embedding systems that are multimodal, right? Because LLMs are not one modality, right? So, for instance, ChatGPT can handle both text, audio, and images, right? And this embedding space is talking about for the Gemini embedding 2 that can use text, images, video, audio, and documents in the same embedding space, right? You put all of this together in this large space, right? And you can think about over time, this is going to be more common, but basically the idea is the same. You take some kind of document or some kind of image or some kind of data, and you represent it in an embedding space. And then by representing these things in the same embedding space, you can sort of see how similar things are. So of course, you can make an embedding space that only uses images. And then you can do an image comparison of how are these images related to each other. But you can have an embedding space that just text and images, and then you can search both with images and with text, right? And I think over time you can think of this sort of paradigm of having multimodal embeddings and having larger sort of embeddings is sort of this thing where we sort of go into more general models that have sort of a larger understanding and takes more compute, right? But some people think like, oh, maybe we don't need these embeddings. And I want to talk about that because there's something to be said about that. So if you look at the LLM side of things, people are just using markdown files, right? They're just taking a file and they're putting the context in the file, and then your LLM reads the file, right? So for some things, it doesn't always make sense to have embeddings, right? But you can think about embeddings as sort of having an extra safety, right? And usually it doesn't cost you anything extra to have embeddings. So for many systems, for instance, OpenClaw, which is an agent system, they have embeddings, but they have other tools for searching too, right? So for many systems, embeddings is something that is used, but sometimes you don't need embeddings. It can be overkill, right? So if you only have a few documents and you're using an LLM, you can just put the documents inside the LLM and ask the LLM to search for it. And that's going to work quite well. The only problem would be like cost. If you do that a lot, it's going to be costly. But if you think about how it actually works, if you're using a retrieval augmentation system, then the document will still be stored in the LLM, right? Or with the concept of LLM. So I would say that depending on your use case, embeddings can be great. Sometimes when you're using LLMs, you don't need embeddings. You can just have another system for just relying on sort of markdown files or just text for the LLMs. Right. We're talking about this sort of going forward. We're going to have a project when you will do something with embeddings. And the thing that we're going to do is sort of looking at like, okay, can you make a data set? Can you make a classifier? And can you make a demo of this classification model? And here's some example of an idea that could be interesting. This is a data set of ICD-10 clinical codes, which is sort of clinical codes like, okay, what disorders do you have? And looking at like, okay, can you train a classifier? This is just one example of what you could do. Another interesting idea, can be complex, can be interesting, is looking like, okay, most of these systems have something called deep research. When they search for query a lot of documents and try to find, okay, which documents are used for this, sort of like, okay, I want to learn everything about what's the link between, let's say, creatine and sort of productivity or something, or caffeine or something, right? And then it sort of searches online for documents and sort of gives you the output. And these systems sort of rely on sort of figuring out ways to sort of embed the data so you can search this in a nice way. And I think this could be a really cool idea to see like how far can you go in sort of implementing this system. And in the source code I'm linking, there is sort of the things you need to sort of get started. But you sort of need to figure out a nice way to sort of figure out how to search for this data in a nice way, right? And if you want to sort of understand the transformer, which I think this resource for annotated transformer could be nice to sort of look at, like, okay, how does the transformer work? And this is sort of the paper we published, right? And then in the next lecture, we're going to talk about content engineering to sort of understand how we can use this sort of limited input of LLMs and still sort of be productive. But before that, I'm going to take a break and I'm going to talk about what's going to happen in the lab.